Good afternoon, everyone. Welcome to the presentation of the Terrarium Group 01. Our presentation is about saving the coral reefs by using the biorock. We will introduce our project into four sections. The first one is project brief. The second one is constraint for the project. The third one is project requirements. And the last one is functional analysis. The project brief. Our project aims to save the endangered species of coral by using the solar-powered portable devices. The coral has known not only playing an important role in environmental regulation and industry, it also shows its unique and irreplaceable position in pharmacy and retail business. However, due to humans' massive, immoderate exploitation and significant climate change, many coral reefs, including the Great Barrier Reef, are facing the threat of bleaching. The direct impact to the coral is 24 species are facing threats, whereas 2 of them are facing the extreme risk of extinction, and the bleached reef is unrecoverable if their environment cannot improve. Our project may bring a chance to save these invaluable coral reefs. By artificial cultivating use these portable devices, we will be able to control the environment of the reef's growth. And with numbers of these devices, we will be able to create an impressive amount of small reefs, either to replace the bleached nature reefs or can be the substitute of the nature reefs, which are greatly applied in industry or pharmacy.
Based on the project brief mentioned before, our task is to design develop a solar-powered and individual household terrarium that is convenient for customers to carry. And it could also maintain corals inside life by itself. And the customers who purchase our product should easily feed corals by using our terrarium.
Okay, now let's take a look at the assumptions and constraints for the project as identified. And so totally I have generated 9 different assumptions and constraints. And the first and 2 is no technique that does not consider and will appropriate incorporate traditional culture and knowledge systems should be implemented. The second one is no technologies and designs that do not seek to make stronger connection to country, culture, and communities. Faster financial sustainability and economic development should be implemented. These two constraints comes from the project scope. And the third one is designs that cannot transport the terrarium manually should not be considered. The reason why I put it here is because that according to the project scope, it is said that terrorism is used for educational use and it should be transported from schools to schools. So, for example, if a professor of ANU have finished his class by taking the terrarium and he has to giving out another lecture in the University of Canberra, so he has to take the terrarium manually and take them to the next institution that he have to give out the lectures. So if the size is too big or the weight too much, is too heavy, and the terrarium is not convenient for manually transporting, so does not make sense. And the fourth one is designs that fail to minimize waste, and the designs that fail to minimize waste, utilizing everything and maximizing sustainability should be abandoned. And this constraints here is used for saving the cost and avoid wasting when designing the terrarium. And next one is no measure that is unsafe, unrobust, inappropriate should be used. So the terrarium may made by glass or plastic. So during the process of experimenting or transporting from a school to another school, and it may face the safety of maybe being dropped on the floor or hit by others, so it may be broken. So the terrarium must be safe, robust, and appropriate for use. And next one, the coral should not be invisible, as the terrarium is used for education, so the students should clearly clearly see what the coral looks like inside of the terrarium when the professor are giving out the lecture. So the coral must be visible by the students when they listen to the professor. And next one is no unrenewable energy source should be used. The reason why I put it here is, so for example, if we use the coal to make some heat and to maintain the temperature of the whole coral terrarium, and the coal may produce some bad air or bad atmosphere when burning, so it may does harm to the environment. So this kind of energy is not renewable and should not be used. And the next one is unit that cannot be used and maintained by individuals without the extended background in coral cultivation should not be used. So as the terrarium is used for education, so the students may have some opportunity to see and to do some experiments by themselves. So the students have no background of coral cultivation, and they should use it easily. So the designing should be that can be used by everyone, not only the professor but also the students. And the next one is designing plan that costs more than $300 should not be considered. This constraint is used for saving the unnecessary money when designing the whole project. And that is all the key assumptions and constraints for the project as identified.
We have separated our system boundaries into 3 different sections. They are internal, external, and excluded. For the internal part, we have included almost every hardware devices for our portable device, such as solar cell, DI filter, heater, and the water pump. And also we have included the size, shape, weight of our device. And for external, we have set the conditions that might affect our portable device, such as the temperature outside, the coral, the voltage, and also the battery life. For the excluded, we are not considering them for now. So they are weather, holders, and animals which eat the coral. 3. Requirements. Stakeholder analysis and design criteria of the project in the form of quality function deployment. Stakeholder analysis. We have separated our stakeholders into 4 parts. They are external support, coral reef protect legacy, individuals, and parallel industry. And we have labeled the relations between these stakeholders by arrows. And as we can see, the coral reef protect legacy and the external support shows the most significant importance in the stakeholders. Quality function deployment, also known as QFD.
Before we start to develop the metrics, we divided our requirements into 3 types. The basic inner conditions requirements, the hardware and appearance requirements, and the stability requirements. In basic inner conditions requirements, we concluded the requirements like light, saltiness, pH value, calcium content percent, and the temperature of the water. And since are the most basic and important requirements for terrarium to successfully feed corals alive, we believe that it should take about 50% of the total weight. And then we list those hardware and appearance requirements, like the maximum weight, the maximum capacity, and the least battery capacity, the control system of the terrarium. And those are necessary requirements that our product should satisfy with, so as the weight and size of the terrarium will be portable for customers to carry, and they could easily adjust the inner condition with the auto and manual control system that we provided for our terrarium. Finally, we assign 20% to the requirements on its stability when the power supply of the terrarium is mainly comes from the sun. This is also an important requirement for terrarium so that it could be self-sufficient based on the solar power from the sun. And the detailed information of the 11 requirements could be seen in this page. And based on the 11 requirements, the corresponding 11 design criteria that could be traced back to the requirements above I've also been developing and calculated its weights out in the final QFD table.
4. Functional analysis includes function breakdown structure and function flow block diagram. For the function breakdown structure, also known as FBS, we have one main function, which is solar-powered coral terrarium design. And we have breakdown into 6 small functions, which are namely receive and store energy, provide light, monitor and show data, adjust the temperature, produce water quality suitable for coral, and create a similar marine environment. For the function flow block diagram, also known as FFBD, we have 3 inputs, which are namely energy, individual, other small marine organisms. And with arrows pointing to the functions, it leads us to the 4 outputs, which are gets enough light, stable water temperature, water suitable quality for coral growth, and enough food respectively. Thank you. This is the end of our project presentation of using the biorock saving the coral reefs, and the reference will be given on the next page.